So combination is when order is not significant, and it's going to be signified in your questions with the words choose or select. So the main difference where combination is different from your permutations is that the order does not matter for combinations. So as the word suggests, it's just a combination where the order doesn't matter, so there's no arrangements, there's nothing like that. Combination is specified by a big C you can see here. And you'll see that on your calculator as well. And you press shift something and you'll get that C up. Now the equation for combination is n factorial divided by r factorial times n minus r factorial. Yeah? So just something you need to memorize. But to help you memorize it, you can see that this n factorial on n minus r factorial is actually exactly the same as your equation for your permutation. It's actually your permutation, NPR, just divided by an extra r factorial. So the only difference is with combination is that firstly, order is not significant and it's going to be divided by an extra r factorial. So this is our definition for combination. Let's get used to working with NCR before we move on to the questions with arrangements and selecting so on. So in question 1, we want to evaluate the following. So let's write the equation up here. So remember NCR. Now don't expect you to memorize this straight away, so that's why we're writing it up here, but hopefully by the end of this module, you'll be familiar enough with it. So remember, it's just your n factorial over n minus r factorial. So that's the same as your permutations, but it's divided by an extra r factorial. Okay? So with 5c2, that's going to be 5 factorial divided by 2 factorial, your r, divided by 5 minus 2 factorial. So that's 3 factorial. And just put that into your calculator and get 10. All right, what about when it's 8c1? Well, that's going to be 8 factorial divided by 1 factorial, which is your r, 8 minus 1, which is 7 factorial. All right? And in this one, you can either put in your calculator or just quickly work it out in your head. So 1 factorial doesn't mean anything here. 8 factorial can be written as 8 times 7 factorial, and that cancels with that 7 factorial to just leave you with 8. What about 6c0? Just put that straight into the equation. So 6 factorial divided by 0 factorial, that's your r. 6 minus 0 is 6 factorial. Now the important thing to know is right at the start of factorials, we taught you that 0 factorial equals to 1. And so we have to use that here. So this just becomes 6 factorial on 6 factorial, which equals to 1. What about when it's 3c3? Well, then we have 3 factorial divided by your r, which is 3 factorial, and you have n minus r, which is 3 minus 3, so it's 0 factorial. So in the same way, I know this equals to 1. 3 factorial and 3 factorial just equals to 1. And finally, we have 8c9. Now, in this case, you're going to have 8 minus 9 here, which is negative 1, and you can't have a negative number factorial. So that's why that's undefined for that question. Just remember, this equation here is the same as your permutations equations, just with an extra divided by r factorial. Yeah? And you'll get familiar working with it, but for the most of the questions you will do later on, we'll be using calculators. But why we need to understand this is to work out these type of questions, yeah, where we're working with just the combination itself. So let's do question 2 now. So here we want to simplify 15c11 plus 15c10. All right. Now I'll write up the equation for you up here again because I'm feeling very nice today. So we have n factorial divided by n minus r factorial, and remember, just an extra r factorial for your combination. So for 15c11, we're going to have 15 factorial divided by 11 factorial multiplied by 15 minus 11, which is your 4 factorial here. Whereas this one becomes 15 factorial divided by 10 factorial multiplied by 15 minus 10, which is your 5 factorial there. To simplify that, somehow we have to put that together, right? And how we're going to do that is try and find a common factor. So I'm going to have to simplify this, so I get a 4 factorial, and simplify this, so I get a 10 factorial essentially. So this becomes 5 times 4 factorial, and this becomes 11 times 10 factorial. Now you can see here, I have 15 factorial divided by 4 factorial times 10 factorial. And here I have 15 factorial divided by 4 factorial and 10 factorial. So that's my common factor. So I can take that out, and what I'm left with here is just 1 on 11. And what I'm left with here is 1 on 5. All right, now I want to put this together into one fraction. So I multiplied this by 5 in the way that this 5 on 5 and this by 11 on 11. So this bottom here will just be 11 times 5. Now I'm leaving that as that is for a reason, all right? And up here will be 5 plus 11, which gives us 16. Now you may notice the reason why I'm leaving this like this here is you can see we have 5 and 4 factorial, yeah? And 11 and 10 factorial. Can you see what I'm doing with that? Yeah, exactly. So over here, we have 15 factorial times 16, and 4 factorial times 10, and 11 and 5 there. And why we left it separate is because I can put the 11 in front of the 10 factorial, the 5 in front of the 4 factorial, and put them together, yeah? So up here, that just becomes 16 factorial, that becomes 5 factorial, and that becomes 11 factorial. Can you see that? So I just get this. And now I look back to my equation here, and I see, well, n has to be 16, but r in this case could be 5, right? So it's going to be 16c5, or imagine if it was 11 as well, and you would get 5 factorial from 16 minus 5 anyway. So it's going to be 16c11 or 16c5. So either of those is going to be a simplification of what we have up here. All right? Okay, so what we did here is we knew we just had to put the equations together. So we found a common factor, took that out, and then we were very smart over here, and we saw that because we had 11 and a 5, we didn't multiply them together quite yet because we knew we could put the 11 in front of the 10 and the 5 in front of the 4 to make a 5 factorial and 11 factorial. Great. Let's move on to question 3 now. So here I need to solve nc2 equals to 55. So let's put that into the equation. So remember, that's n factorial divided by r factorial times n minus r factorial. And that equals to 55, all right? And now I want to cancel that. I want to get rid of the factorials because otherwise I can't really work it out if I have an n factorial in there. So I can make n factorial into n minus 1, n minus 2 factorial, yeah? And that just cancels. So I'm left with this. And 2 factorial is just 2 times 1, was just equals to 2. So I can just make that 2. And now I've just multiplied that across. And this is just going to end up being a quadratic. So that becomes n squared minus n minus 110. And I just need to factorize that. And what that's going to factorize to is 10 and 11. And because I want a negative n, I know this has to be the negative. So I get n minus 11, n plus 10 equals to 0. So n equals to negative 10 or 11. But remember, we're working out an n in terms of the combination, right? So that n has to be a positive integer. So therefore, n must equal to 11 there. All right? Excellent. So you can see here, all we did was put into the equation and do a little bit of simplification. But an important thing to note here is to not lose sight of what the n is for. So remember the n is for this combination, so that's why I had to be a positive integer there. Great. Okay, let's have a look here. Here we want to solve nc3 equals to np2. So here we're putting the combinations and permutations equations together to try and solve it. So let's just first put the combination into its equation, which is n factorial divided by r factorial, so that's your 3 factorial, n minus r, so n minus 3 factorial. Now remember, with permutations, you can either put it into the equation, or the other thing you can do is just work out the factorial of it. So that'll be n minus 1, n minus 2, so on. But because it's np2, I know I only need the first two. So that's n and n minus 1. Okay? All right, now I need to do some cancelling and so on. So first thing I can do is change this to n minus 1, n minus 2, n minus 3 factorial. So this and this is going to cancel. And if I divide that over, the n minus 1 over, right, that and that is going to cancel as well. And what else is going to cancel? The n and the n. So we've just gone an extra step here and gotten rid of that. So that and that cancel. So essentially I have n minus 2 on 6 equals to 1. Yeah? Just multiply the 6 across. N minus 2 equals to 6. Therefore, n equals to 8. All right? So even though it looks quite difficult here, you just got to think, like I told you before, I need to get rid of those n factorials somehow. So I'm going to change that n factorial to have an n minus 3 factorial, so I can get rid of my factorials in that way. Let's have a look here at a proving question. Now, this is incredibly popular for your exams, and I've seen this many times, so it's good that we're learning this now. So we want to prove that NCR equals to NCN minus R. And this is how we do it. First of all, we write out the equation, n factorial divided by n minus r factorial. Now, all I've done here is I've added a n minus n, yeah, which equals to 0. So I haven't changed anything essentially, but I've added that in, that n minus n. And now I want to factorize this. So I'm going to take out a negative from here, so this becomes positive. I'm taking out a negative from positive r, so that becomes negative. All right? Let's look at the equation, which is n factorial, n minus r factorial, and that gives you NCR. Now, have a look here. This, although you might think that n minus r factorial is this, what it actually becomes is this whole thing essentially becomes your r. So let's consider this k to make it simpler for us. So imagine this whole thing is k. So can you see how we've actually written it as n factorial, k factorial, n minus k factorial? Just like that, yeah? So that actually becomes NC n minus r, because that k equals to n minus r. So can you see how I've gone from this step to this step? So this is usually the most confusing step for students, but just consider that as k, and you can see how we get NCK. And since we let k equal to n minus r, that's why we have NC n minus r. All right, so that's how you prove that question. It's actually not too much work, is it? You just add in n minus n there, and then you reconsider this into n minus r. Now, why this is useful is sometimes it does help you to solve other questions. So for example, in the next question, here we want to solve NC3 equals to NC7. We can write it all out, but an easier way to do this is to know that NCR equals to NCN minus R, yeah, which we just proved. So NC3 is exactly the same as NCN minus 3. And that has to equal that. So that means n minus 3 has to equal to 7. So therefore, n equals to 10. Yeah? Really simple, isn't it? Just by using this proof here. So that's why we did that proof there, and you can see it comes into use And a lot of time in your exams, what they might do is ask you to prove this and then solve something like that.